Cool. So, hi everyone. Thank you for having me. My name is Stuart, and just a little bit of info about me. I love all things C Sharp, F Sharp, and .NET. I blog at stu.dev, and if you want to get hold of me, then that's where you can find my link to my Twitter, and my DMs are open if you just want to chat. Today I'm going to be talking about C Sharp 10, obviously, as the talk title suggests. And as the title also suggests, C Sharp 10 isn't out yet. So this is a sneaky peek. It is out soon. So anything I say today might change, but there's a good chance it won't. It's settled down. It's settled down now. And if there's a show-stopping bug, they might pull a feature out or change the behavior slightly. But it should be pretty representative of what we'll see next month. And just to sort of recap on where we are today, we are here. We're enjoying .NET 5, and .NET 6 is just around the corner. So Microsoft is now committed to this release cycle of every November, once a year, they'll release a new major version of .NET. So it's nice and simple now. We've got .NET 6, 7, 8, 9, etc. And this is also how Microsoft is shipping major versions of C Sharp. So today in .NET 5, we've got C Sharp 9. And we'll get C Sharp 10 with .NET 6. And if you just add 4 to the .NET version, you'll have the C Sharp version for the foreseeable future. So it keeps things nice and simple. Just to kind of explain a bit more about this diagram, this top track here is the long-term support releases. Depending on where you might work at an organization that requires you to only use these releases, in which case .NET 6 is much more exciting than the other releases in terms of we'll be jumping 2 versions. So you may be using .NET Core 3.1 today, in which case you're probably using C Sharp 8. And so that's 2 version hops. Today I will be talking about some C Sharp 9 features because some of them have been the themes have been extended upon a C Sharp 10. And I'll also be talking about C Sharp 11 features that we won't get until next year. But some of them are quite interesting, or some of them were aimed for C Sharp 10 when I was originally putting together the talk and have now slipped out. So I'll have a few of those in there as well. If you want to get hands-on with C Sharp 10, there's some really good options at the moment. We've got .NET 6 releasecan.1, which you can download from this link here. This is the same link you get if you do .NET-info. And when you have .NET 6 RC1, you want an ID that has support for the C Sharp 10 features. So that'll be Visual Studio 2022 Preview 4, or you can have VS Code, and you just need the latest OmniSharp extension, C Sharp extension, and that will just work. Rider as well, the latest EAP for Rider also has C Sharp 10 support or partial support. If you don't want to install a preview SDK, and I get it, then LinkPad 6, if you're on Windows, is a really good option. That's in beta at the moment, and there's a preference you can get to in the preferences to say use daily Roslyn builds. And this is great because you can just, anytime a new feature lands in the Roslyn branch, you can try it out. So that's a really nice way of getting hands-on with it. And there's also SharpLab.io, which is a really amazing website. I'll be showing that later. But that's if you don't install anything at all, you just want to have a little play around. It's a great little sandbox to try this stuff out and to try out various feature branches of Roslyn, which is the C Sharp compiler. So I'm just going to start talking about various C Sharp 10 features. If you've got any questions, put them in the chat, and I'll come back and revisit it at the end, and I'll scroll back the slides and we can talk about it and get into some of the detail. Apologies, I've clicked my own link. So the first one I want to talk about is file scope namespaces. So this is what a typical C Sharp file looks like. And there's a lot of white space we tend to have in C Sharp. And if you've got methods, you've got even more white space. You've got like 3 layers of indentation. And a lot of it just isn't necessary, especially that namespace one, because that namespace sort of indentation block kind of spans the whole file. We tend to have this in every file in our projects or solutions. And so the C Sharp language team have come up with a feature that's now going to make this better for us. And that's called, the feature is called file scope namespaces, but the syntax is called namespace declarations. So this is the space we'll be able to get rid of. And the way we do that is by turning that top namespace block into a namespace declaration with a semicolon at the end. So if we add a semicolon, we can now remove the code braces and de-indent the whole file. And that's great because we can just apply this to a whole solution, right? So in Visual Studio, you'll get the Roslyn code fix, which is like a little light bulb where you can say apply this change to the file, the project, or the solution. So you can really go wild with this. Obviously, be careful with that because that's going to be a massive code commit. It's going to be a massive git diff. If you look at it just in terms of like ignoring white space, it's only 3 characters that change. But obviously, if you include the white space, that's pretty much every line in every file, right? So yeah, be careful with that when you come to merge it in. But I'm definitely going to be doing this to pretty much all my solutions as soon as I can. What I love about this feature more than anything else is most language features have some kind of trade-off. And I feel that this one really doesn't. It's like just a win. So I really like it in that sense. One thing you may be asking is what would multiple of these declarations, these namespace declarations in one file mean? And the language team couldn't decide amongst themselves when they were designing this feature, and they were split down the middle. Half the people felt that that would be a nested namespace. Half the people felt that that would be like an adjacent namespace. And so they've decided to not decide, basically, and make it illegal. So you'll get a compiler error if you try and put more than one of these in a file. If you want multiple namespaces in a file, which generally we don't, you would use the old syntax. But for everything else, you use this nice new syntax. What's also great is that this is now the default in the new templates. So when you say .NET New with .NET 6, all the files will now have this namespace declaration. So you'll be seeing a lot of this, basically. Another feature in a similar kind of space, I guess, is global usings. And so if we take that same file, we just tidied up there with that namespace. Often we have namespaces we need to bring in to our file, and we have the top of the file using system, using whatever. And in this case, we have a couple of properties that are string and int, and those are compiler keywords and the aliases to system string and system int32. So we don't need to bring in any namespaces here, but as soon as we start to get more complicated, we get what I refer to as the usual suspects. So let's say we added a date time property and a collection. We tend to add, using system generic collection, using threading tasks, writing async code, and we're forever doing I think as C# developers, especially us who's been doing this for a while, we tend to see through this noise. We kind of mentally subtract it, but it's there, and we're forever churning the same code, and it's just a waste of space, really. And so Microsoft now decided to kind of address this and help us tidy it up with a new feature called global usings. So what you can now do is on the top line here, you could say global using system. So just add the global keyword here. If you were to do that, what that will do is that will implicitly bring using system into every other file, including this one, across the whole project, so the whole compilation unit. Now, if you were to do that here, you'd be a maniac, because if you were to sprinkle these things around all different files, it would be out of control pretty fast. So what Microsoft is suggesting is that you put these in a centralized place within your project. And so you might do something like this. You might have global usings.cs, and then you could put, the usual suspects all tucked away with this global keyword. And now in all the other files in that project, you don't need to bring it in. So you can kind of clean things up. And so in this file, there's no extra namespaces required. So that's a really nice feature. In terms of the syntax of this feature, you can do anything you can do with a using namespace in its current form. So for example, if you can do using my alias equals some namespace or some type, you can do global using. So to make it clear, you can do other forms of using statements. So for example, using static as well. So this using static lets you bring in any static methods on a class into the namespace, and you can do that with global using as well. Something they've also done is they've sort of leaned on this in the new .NET 6 templates. So they've added a feature where you can switch on implicit usings, and it looks like this. And they did play with this during the preview phase of .NET 6. So they did have this on by default, and people upgrading projects found that it was a bit counterintuitive. The project suddenly broke. So if you're upgrading from .NET 5, this is something you have to add yourself. But if you do a new, .NET new in a .NET 6 project, this is going to be included in the default template. So you'll see this implicit usings enabled or enable. And when this is switched on, what this does is inside the SDK itself, it has this, it has these item groups that are guarded by that that property, the implicit using property, and it brings in these new items called usings. And what it will do is, just like with your project properties in your CS proj file, it will code generate a file for you, just like with your assembly info version or whatever it is. Just like that, this gets code generated. So you'll end up in your OBJ folder with a file like globalusings.g.cs. And what that will look like is this. So it will auto-generate these defaults for you. And so these are some sensible defaults Microsoft have kind of come up with that they think make sense. So if you're doing a console app or a library, you'll get these usual suspects, hopefully very familiar to all of us. If the project you're working with is a worker template, you'll additionally get these Microsoft extension namespaces, which is configuration, dependency injection, hosting, and logging. And if you do a web project, a web SDK, you'll also get these ASP.NET Core familiar namespaces. So this is one of the driving factors for this feature, is they want to consolidate some of the namespace fragmentation that they've had in .NET and in ASP.NET Core. You also, in the web one, get this one as well, the systemnet HTTP JSON, which gives you extension methods on HTTP client for dealing with JSON content. So that's quite nice. Like, you just switch that on. And so for .NET 6 and new projects, you kind of have this kind of nice default where you don't have to worry about including system link everywhere. It's just there. You can also use this in your project yourself. So I showed that you can do like a global usings.cs file, but you could yourself in your projects do a item group and use these usings. So you could define it in your project file. When you do that, you can do anything you can do in the C# form as well. So you can say alias equals my alias, or static equals true for global using static. And you might want to do this if, let's say, you wanted to do it not just for one project, but a whole solution. You could then use like directory.build.props that include a whole solution-wide set of namespaces. You can also use this to ship usings in NuGet packages. But be careful with that, because as Microsoft found, if you just start shipping global namespaces, it's people generally don't like it. They like to opt into it. So the recommendation is, do include if you've got a popular NuGet package, do include global namespaces, but have them behind a feature tuple, basically, that people are going to opt into. The next one I want to talk about is record structs. So this is records is probably the biggest feature from C# 9, and records are a way of defining types that have a different set of defaults that are better suited to value objects in domain modeling terms. And just to sort of familiarize you with the syntax, if you haven't used it before, you can use this shorthand syntax for records in C# 9. You can say record coordinates, and then just have some parameters that will get turned into properties. And you have to use this semicolon in that short form. Or you can just use it like you define a class and have the properties define yourself. And they also add in C# 9 this init keyword. And this is a way of saying, this is an initialize only property. And it's useful for having an immutable property that can be set through object initializer syntax. So whenever you say new coordinates, you can use curly braces and have immutable properties. That's what this feature added. And this shorthand gets turned into these properties basically for you. The code generation under the hood gives you this. Now in C# 10, they had to think about the syntax here, and they realized that actually they wanted to kind of change the semantics of record, or change kind of what it means in the language. And so they decided that actually record is really a modifier for class. So in C#10, you can now say record class coordinates, and you can do it in either way as you did before. And that's the same as saying record coordinates. And record coordinates, that will still work for backward compatibility purposes, but really you should think of record as a modifier for a class. And that's because they've added record structs. So this is how it works for structs. You'd say record struct, and that's a modifier for a struct. And as you might expect, they've enabled the short form syntax, so you can use that. Or you can use that long form as well and define the properties yourself. Something that may catch you off guard, if you've used records from C#9 for classes, records tend to be immutable by default, or they certainly are with classes. With structs, they had a bit of a struggle because there's already a way of defining immutable structs versus immutable, and that's with the read-only keyword. So if you want immutable structs, immutable records, which you almost certainly do, you need to say read-only record struct. So that's the only gotcha here. You have to remember to say read-only. And to kind of explain why, I'll just show some code quickly. So this is SharpLab. I've got here's one I made earlier. And hopefully you can read this code. So SharpLab's great, by the way, for those who haven't used it. You can click on this drop down and change it from the default branch, which is like C#9, to the Roslyn main branch if you want to try out C#10 stuff. Here I've defined a record struct. And just so you can see what happens under the hood, the compiler generates a type for us, and it's a struct as you might expect. My mouse wheel's not working, so let me just grab this. You can see here that the properties it's created for us from the short form, it's also, they're automatic properties. We've got the get sets. If I say read only, then you'll see that you have to trust me that nothing's changed except for the properties now, instead of having setters, have the init properties, so they're now immutable, which is what you want. If I scroll down a bit more, what you also get with a record is a pretty print toString method that has all the properties pretty printed, all the members on it. And importantly, it has an implementation for the equals, not equals operators, equals method, that are all based on structural equality or value equality. And same for get hash code. The get hash code mirrors or matches the that value equality. And that's why you want immutable properties, or that's usually why you want immutable properties, because if you had a mutable record and you use that as a key to a dictionary, if you change the property on that record, you've now changed the hash code, and now you've basically lost the key to that dictionary. You've kind of orphaned something in that dictionary. So you typically want records to be immutable for that reason. So you also get a constructor, a deconstructor that matches the constructor. So it's just a very handy way of having some sensible defaults in your types, and have that with structs. Something in this competency code here, actually, let me go back to the slides for this one. When you're working with immutable types, you want a way of like still being able to change things, but obviously the type itself is immutable. The instance doesn't allow you to change it. So in C#9, they added the with keyword, and that lets you copy a record with a change. And so obviously they've made that work for record structs. But in doing so, they realized actually, so the way that the with keyword works is it needs to know how to clone the, here's my pointer here, clone the instance it's working with. And so with record classes, it would synthesize a clone method on the type. But with structs, they're inherently clonable because it's copy by value by default. So all they need to do for structs is make them work with the syntax. But actually they realized, well, you might want to do this with a plain old struct rather than just rather than a record struct, because you can clone a struct. So you can use the with keyword with plain structs, not just record structs. And you can also do this with anonymous objects as well, because the compiler knows how to clone those things as well. If you want to know more about records, there's a really good talk from David Wenger on NDC Melbourne. It's a really good full-length talk that dives into structs, record structs, and the stuff under the hood. If you want to know more, definitely there's a full talk to be had with it for sure. I can recommend this one. Better lambdas. So this is probably, I don't know, I think I said I think I said namespaces, file scope namespaces was my favorite feature, but actually I think the lambda improvements are probably my favorite. So lambdas in C# have been around since C# 3, and they were introduced to enable link, and they're probably one of the most, well, in my opinion, the like fundamentally the biggest change to C# in its history. And they're amazing, but they haven't really changed since the introduction. And there's a few issues with lambdas, I feel. One is the feature gap between lambdas and methods. So there's things you can do with methods you just can't do with lambdas, like attributes on methods, attributes on the parameters, in, out, ref parameters, return types, lots of things you can do with methods you can't do with lambdas. And the other thing is just the usability of lambdas in general. And make that clear. With lambdas, you can't just define a floating lambda, if you can't just say var f equals some lambda. The only way a lambda can kind of exist is by casting it to either an expression or a delegate. And so to make that clear, like here, we're literally having to cast it to a delegate type for it to kind of exist. Or you can use the delegate constructor. So when, just take, for example, when you have the select method in link, it wants a particular generic delegate, and that's why you can put a lambda in there. It's because it's implicitly casting your lambda to that known delegate type. But if you pull it out into a variable, you have to do this, and it's ugly, it's horrible. But they're improving this with C# 10. So this is huge in my opinion. I love this. So if we look at F4 here, you can now just say like var F4 equals sub lambda, and that works now. And this feature is called natural inferred types for lambdas. So the compiler will now try and infer a natural type for the lambda you have. And on the next line, here it will infer an action of int. If you use async, it's going to infer task. So here we got func of task event. And it can also do this for method groups. So here we can say dot get hash code without the brackets, and that's a method group. And it's just going to infer the delegate type for that as well. But that only works where there's one overload for that method group. So if we look at this next line, we've got int toString that has lots of overloads to it. So the compiler doesn't know which one to pick. So that one won't compile. Other things that won't work at the top here, F1 here, we don't know what that null we're returning could be. It could be any reference type. It could be a nullable value. F2 here, we're not using that input, so it's not going to infer what that input type is. Actually, even if we were using it, it's not going to infer. It's not like F#. You have to tell it the input types, basically. And also on F3 here, it's not going to auto generalize for us. It's not going to figure out that, oh, you're taking X and you're returning X. It's not going to just give that type T and figure it's going to return type T, as some functional language might. But to fix that that top one, they are also adding explicit return types to lambdas. So now you can say on this bottom line, string, and then the lambda, and that's the return type for lambda. So here it knows that null is actually a string, and it's going to infer the type for that. Oh, I said error, that shouldn't be error. But so yeah, that's a big one as well. So you can now have return types. When you're using return types, you can't, in lambdas there's a special case where you have one parameter, you can omit the brackets. That's no longer a thing when you have the return type, because the compiler can't do the parsing gymnastics required. So if you are going to use a return type, you have to have the brackets in there. So that's huge in my opinion. Like, I love this. This is super awesome. Something else you can do that they've added is attributes with lambdas. As I said before, this is closing that gap on methods. So you can now put attributes on parameters in the lambda, like this, or on the lambda itself, just like you can put an attribute on a method. And if you want to put an attribute on the return type, you can also do return : the attribute, and that will apply to the return type. And that's going to be super useful, as we're going to see in a bit. And that's because a number of these C# features have all come together and have been driven through this use case from the ASP.NET Core team to help people build simpler APIs, and they call this minimal APIs. And it's a number of features that will come together. So in C#9, we had top level statements. This is the ability to just write code in a file for entry point application and not have to have a namespace and a static void main and a program class. Global usings, which I've just shown the explicit Lambda return types and attributes and inferred lambdas. And taking advantage of all this, the ASP.NET Core team have added some new APIs to make it a really simple, like great framework to start out building simple web applications. And to make that clear, here is like the simplest API starting in .NET 6 if you're building a web API. And the amazing thing about this isn't a snippet of code. This is the full app. This is the one CS file with 3 lines of C#. This is the whole thing, and you can .NET build and run this. And that's because it's using, as I said, top level statements. So we don't have to have a main method. It's using global usings. So all of those ASP.NET Core things and system namespaces all tucked away. We can see here it's using the new Lambda improvements. I'll explain in a minute why that's important here, but that's being used here. And it's just super simple. And this is something that other frameworks like Node.js or Express.js, I should say, and other ecosystems have all these really simple examples where people can get started and kind of grow it up without this sort of concept overload. But what's amazing about this as well is that this does grow up as well. You can do more complicated examples with this. So, you can grow it all the way up to a full MVC app, or you can stay in this kind of minimal API world and move things into separate files. Here's a more involved example. This is from Damien Edwards. And in this example, the Lambda we're taking can now take any sort of shape at once. And so in this case, it's taking a to-do DB, which is an entity framework thing. And that's a service that lives in the service collection. So you could be explicit and use attributes, which is obviously a new C# 10 feature. We can put an attribute here. You could say from services, and that's going to be explicitly resolve that from the service collection. Or you can just omit it, and the framework, ASP.NET Core is clever enough to figure out that that's going to come from the service collection. It's just going to resolve it for you. And you can use attributes just like you can with ASP.NET Core, with MVC. So you could have an authorize attribute on the whole Lambda itself. Or what's kind of cool is that, what's more idiomatic for this kind of builder pattern is to have extension methods. So there is a .authorize extension method. And here, these are the things that are typically attributes in our controller action methods. And they're now just extension methods. So you can have like the produces to do type for your open API definitions. So that's really cool. It also has this results type where you can say results.ok, and that'll give you a 200 and serialize the payload. This whole thing this results method returns an I result. So that's just like an action method where you have an action result. So it's very extendable. It's very flexible. It's awesome. Here's another example. If you give it a type that doesn't, if I go back to this type, this int ID will come from the root, again by convention, but you can use attributes to be explicit. In this example, to do doesn't exist in the root. It isn't in the service collection, so it's going to deserialize it from the post body, the request body. And it's super cool. And like, again, there's some examples out there, more complex scenarios. What's really amazing about this is you can kind of move, don't think that this all has to be in one file. You can move these to separate files. You can structure it how you want to structure it. But what's really cool about this is it's all leaning on the language features. And so you're in complete control about how you want to abstract it, if you do want to abstract it. Unlike MVC, which is completely convention-based. So MVC is a bit more magical, even though it's a bit more familiar to some of us that used it for over the years. The way that the Lambda improvements have really come to help with this is In the previous version of ASP.NET, you had this version of map get, which is an extension method that takes a path in a pattern and a request delegate. And before, this is all you could do in C#. You had to have a request delegate so that the Lambda could be cast to a delegate. And that had a very rigid shape of like HTTP context and returns a task of something. But now with the new framework, they can just say, hey, we'll take any old delegate. And in our examples, we can put in any delegate we like here and be very expressive. And then the runtime's going to figure out, okay, I need to wrap this and plug in, this from the root and this from the service collection. And so it lets us be super expressive, and I love it. So that's like the headline thing in C# 10, in my opinion. All these features come together to give this really nice experience. Okay, onto a more niche one, which I like a lot. Caller expression attributes. So there are a number of attributes that exist already in C# and .NET called caller attributes. And some of examples of these are caller member name, caller file name, caller line number. And what these will do is you can put them on a parameter to your method. And when you do that, the compiler forces you to make it nullable or optional. And it also forces you, when you call it, to not provide that value. You're not allowed to provide it. And that's because when your code's compiled, the compiler is going to put that value in for you. And it's going to put the value in based on the attribute type. So for example, caller member name is going to put in the name of the method that you're calling from, or the member. So like in a property, it'd be the property name. I chose a poor example here because it's a top level method, top level statement. But the method name of that is main dollar. And so this is useful for like debugging purposes. You can have like, file path and line number. It's super useful to say to the developer when an exception throws, here is where you were calling from, to help you diagnose stuff. What they're adding that's super cool is this new one called caller argument expression. And it takes a parameter, which is the name of another parameter to the method that you would use this in. So in this example, we're naming the input parameter. And again, it has to be nullable. And what it'll do is when you call it, the expression of that parameter. So in this case, it's the literal string of something as string, like that whole part, 3 words as text from the source code. That's the expression that will be passed into the second argument here of input expression. And this is something that seems very niche, and it is very niche. But what's super cool is that they're shipping a method in .NET 6 out of the box that will use this. That's going to be really, really useful, and I'm going to use it everywhere, which is this method here, which is, this is on argument null exception, and it's a static method called throw if null. And what this will do is you can now just do I have an example? Phew, I do. You can now just say argument null exception, throw if null, and pass it an input parameter. And what's super cool is this is going to throw the null argument exception with the name of that parameter, because the compiler is going to pass the name in for you. So this may be familiar if you use like guard libraries. But what's super cool with this is something that hasn't, we haven't been able to do this before, because now the compiler's passing the name of that parameter into the method for us to throw the right exception. So I like that a lot. I'm going to be using that a lot. A friend of mine, Martin Costello, pointed out to me, what's great about this is when you refactor to use this, you've got less branches in your code. So your code coverage goes up if you're not testing your null reference exceptions. So I like that a lot. String interpolation improvements. So there's a couple of new features. One is const string interpolation. So we've been able to do string interpolation for a while in C#, but not with const strings. So things that are compile time static. And we should be able to, right? If we're mixing strings that are compile time static with other strings that are compile time static, it should all work. But we've not been allowed to until C# 10. So they're now finally allowing us to do that. And what that's really useful is, or a place I think it's going to be useful is with attributes. So attributes are only allowed to take in compile time static values. So for example, a root attribute, you can now do string interpolation, const string interpolation. So a nice little win. I like it. Another feature, which is a bit, this is very nuanced. You don't need to know the detail of this, but I think this is super cool. They've added this concept of string interpolation handler. And it's a type you can implement. And it's one of these types where there's not an interface you implement per se, but you build the type and you put an attribute on it to tell the compiler this is an interpolated string handler. And the compiler is going to enforce a certain shape of it. It has to have a certain set of methods. It has to have an append literal method and a toString and clear. And there's rules about its constructor as well. So the compiler is going to kind of enforce this rough shape of what this type has to look like. And what you can then do with it is you can overload methods that previously took string to take a string interpolation handler, your own type. And when you do that and you call it from somewhere that does string interpolation, your overload is going to win. And then you can handle the string interpolation. And there's, to be honest, there's a few places where you'd want to do that, but they are there. There's sort of very low level performance reasons why you might want to do that. The .NET team themselves are utilizing this in a few places like String Builder. They're able to more efficiently let you use String Builder with interpolated strings by using this functionality. But what's, I think, super cool is, and the way that we'll probably get the benefit of this is when we're doing plain old string interpolation. So what happens today in C#9 is when I write a string interpolation thing like this, the compiler does something called lowering when it compiles, and that's rewriting your C# to more messy C# before actually doing the compilation. When it does that, your string interpolation typically turns into a string.format method. And in this case, string.format isn't the fastest way of doing this stuff. And in fact, the second parameter here is an int. The first parameter is a string. So the only overload for string format it's going to find is the object overload. And that's going to do boxing. And it's nothing to worry about, but it's just a little paper cut in terms of performance. And we do this everywhere. The libraries we use do this, we do this. And so it would be nice if this was better. And so what the language team have come up with and the .NET team is they're going to ship this type, this default interpolated string handler with .NET 6. And this is called a well-known type. So the compiler knows about this type. And if the compiler can see it, it's actually going to lower this code to use that default string interpolation type. And it looks like this. So the lowering code now looks like you'll now use this default interpolated string handler like this. And the things to note about it is that this type is a ref struct. So it's stack based, which is super efficient. It can have ref structs or spans as its member. So it will take a span of an array pool borrowed array. So it's super efficient is what I'm trying to say. And importantly, this append formatted method here, if I go back, you can see that it's generic. So that int isn't going to get boxed. And we materialize the string, or I say the compiler is going to materialize the string and give the array back to the array pool at the end. And so it's super optimal. And so just by upgrading to .NET 6 using C#10, we're just going to get a teeny little performance win, which I like a lot. This is a very little one, extended property pattern. So patterns have been approved upon in every version since C#6, and they're getting really good. The feature they've added here is when you're doing nested property pattern checks, you'd need to do this. You have to do curly braces, property, colon, curly braces, a nested property, and now you can just dot through. So if you've got a deeply nested object, this is a bit nicer. And it will do the null check, it's null safe and all that sort of thing. There were going to be more pattern improvements, but some of this has been held off for C#11. So one of the improvements is going to be list patterns. So that's probably still going to land C#11. So there's more to come in terms of patterns. This one is a C#11 feature, and this one was it was originally aimed for C#10, but unfortunately didn't quite make the cut. So to kind of explain required properties, you need to kind of know the problem they solve. So for me, when I start adopting nullability, and by nullability I mean the nullable reference feature that was added in C#8, when I enable that in my projects, it kind of it means I have to go through all my types, and I kind of have to annotate whether they're nullable or not, and I kind of have to go through, and it's a very viral process. But what I find is I have lots of types like this, where I have this person class. Apologies, naming stuff's hard, so don't look at the names too hard. But I'll have a property like public string name, and I'm saying here it's not null because I haven't got the question mark. And what I mean by this, there's no constructor here. Excuse me, there's no constructor here. So I want people to, when they new this up in an object initialized expression, I want them to have to set this property. I want to say it's required. But the compiler tells me no. It says you can't do this. You can't have a non-nullable string in a property because I'm not going to set this in, you're not setting this in the constructor. You can't do this. And I was a bit saddened by this. And I was hoping that the C#9 init keyword was going to solve this for us. I thought, brilliant. If I have a property that's not null and have the init keyword that says, it's an initializer property, then I would have to initialize this when I knew it up. But that's not what that feature means. That means you can only initialize it and set it in the construction, in the object initializer. It doesn't mean you have to set it. And so that didn't work. So what I want to do is I want to express the idea that this property is required. You have to set it. And that's what the required keyword will do for us when we get it. I'm really hoping for it soon. And so just by saying required, what that now means is if you knew this up, you have to set it. And I was a bit confused by this at first because I was like, well, surely a non-nullable string is not optional, and required means not optional. So I'm saying it's definitely not optional. What does that mean? And I saw a talk from Mads Torgersen. I asked him, like, how does that make sense? And he convinced me that they're very different concerns. So to make that clear, you can also do this. You can also say required nullable string, in this case, pet's name. Naming stuff's hard. But what that means is that this property, yes, it's nullable, and you can set it to null, and you can set it to something that could be null, but you're still required to set it when you knew it up. So really, it's about, are you required to set the thing, not what value can that thing be set to? So those are very different things. And I very much want this required keyword because I want to take my existing types, scatter some required keywords in, and then switch on the nullability feature. So yeah, definitely looking forward to that in C#11 when it lands. This is another one that didn't make it. Again, maybe, probably will be coming in C#11. So this is called bang bang or exclamation mark, and it solves this problem. We have a public method that takes a non-nullable string. And this is again with the nullable references enabled. And if this was in a library that you were going to share with people, you would have to check that that string is not null. Even though you said it's non-nullable, you don't know that someone using that library has nullability switched on, or if they're even going to like pay attention to it. They could pass you a string that is null. And so you should probably check it. And the thing with this is you look crazy because you're saying this is a non-nullable string, but go on and check that it's not null. And so they want to add some syntax to kind of say, like, very declaratively, go check that for me. And so it's going to do that same boring code that we always do here for us, just with some syntax on the property, on the parameter. And so yeah, that one's not coming C#10, but next year perhaps. Another one that's C#11 again next year. That this one I'm really looking forward to. I think it's super cool. This is raw string literals, and this is something that you can kind of do in F# today, and I really miss it when I come to C#. And whenever you're putting in some XML or JSON as a literal into some C# code, it's always a bit cumbersome because you always have to escape it, and it depends if it's a verbatim string as to how you escape it and all the rest of it. And in this case, what you can now do, or what this feature will enable, is you'll put in triple quotes, and you can optionally line up the triple quotes at the other end of the on another line, and this is called a multi-line raw string literal, and it will sort of trim anything to the left of that column, anything here to the left, and so you'll just get this part of the string. You don't have to escape quotes. So you can just paste in XML, and the same for JSON, right? You can just paste in JSON. You don't have to worry about those quotes being escaped. What's also cool about this feature is that they are proposing that it works with string interpolation. So in this example, you could put $1 in front of the triple quote, and you can start to string interpolate in this XML. But something that's quite interesting is that if you were to do that with some JSON, that wouldn't work, right? Because you've got curly braces in your JSON, and that's going to immediately escape into the C# world. And so what they proposed is you'll be able to add an arbitrary number of dollars at the front. So if you add $2, that will tell the compiler that you need 2 curly braces to escape into C# land, which may sound a bit, unusual, but is really practical because for that JSON example, you can then very easily start to string interpolate in a JSON literal type thing, which will be super useful, definitely for me. Another one, this one almost made it to C#, but they had to pull it back out because it caused issues with some of the tooling around C#. And generic attributes is exactly what you think it is. So today with attributes, you can't take you can't make them generic. You have to say, if you want to take a type, you have to say type of and pass in a type parameter. But now you can define your own attributes that are generic and take a generic argument. It's not just a prettier way of doing it. It can also take, you can also have generic type constraints, and you can also take generic parameters from a generic type. So you can kind of use it with open generics. So there's actually a thing you can do with it you can't do today with plain old attributes. So I'm looking forward to that one as well. Also, I think it looks nicer. So I'm hoping this lands. And then the last feature I want to talk about, this is a feature that is shipping with C# 10, but it's shipping as a preview. So it's off by default, but you need to switch it on. And this is static abstracts in interfaces. And the way if you want to play with this, the way you switch it on is you need to enable preview features, which again is a new concept for C#. You have to be targeting .NET 6 because it requires a runtime change, just as default interface members or methods in C# 8 needed a runtime change. No, was it 9? No, it was 8. So it needs to be on .NET 6, and it also needs this runtime system runtime experiment package. And I'll explain that in a minute. Basically, they are adding interface implementations to the numeric types, the primitive numeric types that ship with .NET. And hence you need this experimental package. So the feature in its simplest, purest form is this. You're now able to say, for an interface, you can define static abstract like members that it has to have. And you'll typically see it defined as this. You'll have a generic interface where the T is also the generic interface. So it's kind of like this recursive bit of a head scratcher. And when you do this, anything that implements it has to have a static member matching this definition. And this is this iaddable here is an example of some of the numeric the numeric primitive interfaces they want to add. So the idea is by adding like iaddable of T and idivisible of T and any kind of mathsy thing you can think of, and by having the numeric primitives all implement these, you can now have very generic math algorithms. Because you've got a static definition for things like 0, for things like the operators like add and multiply and all the rest of it. And to show you what I mean, like here is how they're going to do it for int32. They'll have it implement iaddable of int32. You already have a plus operator, and then I'm going to add a 0 definition. And then now you could have a method that took a T where T is iaddable of T, and now you can do things like T dot and then a static property. So you can now get to static things on type parameters, which is crazy, right? But what's really good about this is like there's no real performance overhead. You can write very high performant generic maths code, for example. There's other implementation kind of opportunities outside of numerics that I just can't quite think of. I was trying to think the other day of what they would be. For example, like at the moment, if you have a generic type constraint, you can say like that type has to be newable, like with the new brackets. But you can't say like it has an async constructor. Well, you could now define like a I async factory or something, and say that it has to have a static create method that created itself. So you can do things like that. That kind of these things we couldn't express before in C Sharp. So yeah, I'm really looking forward to that one as well. And again, that's behind a preview flag. You have to switch it on. But Microsoft want feedback for this, and then should it go well, they'll kind of switch it on fully in C Sharp 11, maybe with some tweaks. That's all I'm going to touch through today. That's not all of the features. There's other features that. What's great about this sort of talk is I can pick the ones that I think are interesting, and I'm not going through all of them. There's other ones that I've missed out, but you can find out about these yourself. There is, if I hit this link here, there's the C Sharp language design repository. This has all the proposals and specs, and it has all the language design meetings where multiple times a week the C Sharp team come and talk about all these features and kind of hash out these ideas. There's also, and there's probably the best resource, is the language feature status page. This is in the Roslyn repo, and this is a markdown file that contains all of the features. It links off to it shows you the status of them. Are they implemented? What branch they implemented in? You can see all these are merged in C Sharp 10. The definition of the spec. So that's where I'm pulling all this from. This is all happening out in the open, so you can kind of go off and dive in. If you want to see what's coming in C Sharp 11, again, you've got the list patterns, raw string literals. You can jump off here and find out more. And this is a really good page, and it's updated quite frequently. And Mads Torgerson has also done a talk a few months ago on C Sharp 10. I'll share these links with Kevin. We'll get them out there. And so, yeah, that concludes everything I'm going to talk about. I'm going to jump over to questions. I see there's been some chat. Let me catch up, and feel free to unmute yourself and ask questions as well.